Good morning. My name is Jimmy Artrip. I am the computer science instructor at the Knott County Area Technology Center. The project we've came up with is convergence of 3D printing with robotics, a collaboration of ideas in a changing world. When we started this, I was asked, what kind of problems am I having with integrating a blended environment in my classroom? Right now with COVID, it's really hard to do any kind of classes. I've got about 30% of my students in person and the other 70 are working at home. So it was a little bit difficult to get anything, kind of help those kids learn just as well as the ones in person. But as a technology teacher, one thing I could always count on is change. Technology changes every day. Things we never dreamed possible a few years ago, becoming a reality today. So here we can see a computer. It's an old Apple II computer made back in the mid to late 80s. And look how much it's changed just in the last 35 years or so. These are newer computers. So technology is always about change. So I had to ask myself, how can I make sure that students at home have the same opportunity to be a part of these changes while still being at home? How can my in-school students collaborate with my home-based students on new projects? What strategy could I use to solve that problem? And what research question would I need to answer to guide me on student innovations? All of a sudden it hit me. Technology is change. So we can use this change in school procedures to our own advantage. We can set up our classes like a collaborative project, do the same thing that all the companies are doing now. So we decided to break up one big project into several small projects, allow students at home to do one area of that project, while the students here at school did another one. Then they could combine them all together. So I settled on the question, could these students integrate 3D printing with coding and robotics? Last year, I received a grant from KVEC to purchase a 3D printer. One of the items we were able to print was a workable prosthetic hand. We made it with entirely with a 3D printer. So this year I decided to step it up a little and incorporate some automation and programming into some of our 3D prints. So this is just a sample of how that worked last year. It's my little girl, she's got her hand bound up and she's just using her wrist to move around and pick up objects. We made this for like $9 and we were able to give them out to people that were disabled that needed, hands. Okay, so what was going to be the ultimate goal? Ultimate goal is going to be a fully integrated artificial intelligence robot based on the InMove robot design that you see to the left of your screen. We hope that we can begin this project somewhere toward the end of this year and finish up with this sometime in the next couple of years. But before that, we want to get the students accustomed to robotics and kind of get them beginning into more comfortable with the entire field of robotics and programming. So how is this going to be accomplished? This project is going to be done by setting up different sections of the project between homeschool students and our in-class students. The plan is going to be to take the home-based students, let them work with the in-class students to learn Tinkercad, which is a 3D-based 3D design program. They're going to come up with products and product adaptions online. Those designs are going to be shared through Google Classroom, through Google Drive with each group. Once those products are designed, the in-class students are going to be able to print them out and build them while they're here in class. All the students are then going to get together, collaborate on writing the code that's going to automate all these new products. So what products are we going to be using in order to accomplish this task? What I'd like to do with the plan is to start out and begin the year using the Arduino Ultimate 2560 Starter Kit. As you can see right here, comes with like 300 parts they can use to build anything with. And then we're going to use the MakeBlock 10-in-1 robotic kits so the students can learn how to use things like servo motors and integrated circuitry, things like that. After we do that, we're going to make them fully programmable, scaled down versions of things like these grippers. You can see right here, these little rovers have a camera built into them, other various designs. Once the students have made all these products and designs, we're going to start adding coding through JavaScript and Python that they're going to be able to use their phones to operate them, teach them how to use the scripting languages to actually automate the new robots and designs that they do. Hopefully when they learn this basic stuff, as the years goes on into next year, we can actually go in and build the full in-move robot. That's a big challenge, but I think my students will be up to it. How are we going to judge the success of our project? After all this coding is done, we're going to judge the success of our project based on whether the products actually move on their own using our phones to control them. So if they work, they work. If they don't, they don't. There's not hardly any in between in it. My hopes are that this project is going to carry over into better insight, deeper understanding of programming, robotics, and the merging of all these different technologies.